Section 1.1, we're talking about horizontal and vertical translations. So this is like the basis to like everything. Okay, if we figure this out, then we've got most of this whole year figured out. Okay, so all we're talking about is when we say horizontal and vertical translations, horizontal translations just means you're moving left or right. Okay, so if you want to put, oh, hold on, gotta get my pen going. So this is, whoop, left or right. Okay, vertical is up or down. Okay, so when we're talking about horizontal, that's always affecting our x. Okay, so this is affecting our x points, and we're talking about up and down, it's affecting our y's, because our y on the axis is up and down. Okay, so these ones change our y points. Okay, so it says transformations, a change made to a figure or a relation such that the figure or graph of the relation is shifted or shaped, or the change in shape. Okay, so all this means is you're starting with an original, and then you're moving your picture either left or right or up or down. Okay, and then when we get farther, we'll reflect them and we'll stretch them or compress them. Okay, so when we talk about mapping something, oh, that's supposed to be a star. There we go. When you're mapping, all that means is you're describing what you're doing to the points. Okay, so if I was moving my picture up 3, my original points are x, y, and then if I was mapping them, I would say my new point is x, and my next point is y plus 3, meaning whatever y is, I'm going 3 more. Okay, so that would be 3 up. Okay, so then it says translation moves the grass up, down, left, or right. So I said that already. And then this is our first example. And it's from the textbook, page 8. Okay, so it says, maybe we better just make a little side note here. If we're talking about a horizontal translation, if it's negative, you're actually moving to the right. Okay, so it's the opposite of what you would think. So if it's negative, you move right. What am I doing? Is that just make an eraser? Move right. Okay, if it's positive, so that's, we're talking about our x's. Okay, so if we're positive, we're moving left, which is opposite of what you'd probably think. And for vertical, if it's positive, you go up. If it's negative, that means you're going down. Okay, and what we notice when we get farther into these is that if it's inside the bracket, say for here, you'll notice it's in with the x. That's a horizontal translation, meaning it's affecting the x. Okay, so if they're afterwards and they're not in a bracket or after your x, that's a vertical translation. So horizontal ones affect your x, and this would be a vertical translation. Okay, so how can we represent this? If I have x minus 2 like that, that means I'm going to be moving to the right 2 because it's a negative, and when it's negative, I'm moving to the right. So this example here would be moving to the right 2. Okay, and if I had x plus 2 like that in a bracket, that would mean I'm moving to the left 2. Okay, and in a situation, say I just had an x and then I had plus 2 afterwards, so it's not in a bracket, it's not affecting the x. This is moving up 2, so that's a vertical translation of 2. So I would say up 2. And if I had x minus 2 in this situation, no bracket, it's affecting our y's, so then it would be down 2. There could be a square. It just depends on what your equation is. Okay, so your equation could have roots, it could have whatever, and that's what we're going to get. We're going to get into different types of equations. Okay, so in this one, in this example here, we have a squared. Okay, so what shape is that for the equation then? Right, it's going to be a parabola. Okay, so let's look at this example. So it says graph the function y equals x squared. So we're doing that one. A little bit hard to read, but so if we were graphing that, we make a table. This is our y equals x squared. So we have x and y points. So we just pick random x points, right? And then our y's are whatever based on our x's. So usually I pick a couple negatives, a 0, a couple positives. So let's just say I did -2, -1, 0, 1, and 2. Okay. So to find out what our y's are, we plug these into the equation, right? So if I had -2 squared, I'm putting the -2 into this equation. -2 squared is 4. -1 squared is 1. 0 squared is 0. 1 squared is 1. And 2 squared is 4. Okay, so there's our table. So if I was just going to do a rough graph of what this would look like, this would be -2 and 1, 2, 3, 4. Then it would be -1 and 1. Then it would be 0 and 0, 1 and 1, and 2 and 4. Oh, come on. So then our picture would look something like that, a parabola. Okay, this is your standard equation. So when we get into graphing, you always start with a standard picture, and then we're going to shift left, right, up, or down. Okay, so there's always two options that you can do, and it doesn't matter to me which one you do. I'm more of a make a table, switch the points in the table, and then draw the picture after it's changed. But some people like to draw the picture and then move the graph, like physically move it left and then move it up or down. Okay? Sometimes that gets confusing because you might have 3 graphs drawn on your page, right? Because you might be moving it left, then you might be stretching it, then you might be. So what I'm more into is the mapping, I guess is what it's called, where you're going to actually change the points on your graph. Okay, and the points on your table, and then once you do that, then you'll be able to graph one final product. Okay, so it says graph these functions. So if I'm graphing this one now, what I was saying was, what kind of translation is that? X squared plus 2. Yeah, it's vertical and you're going up 2. So all that means is all your y points are being moved up 2. So what you could do is take your y point, go up 2. Take your y point, go up 2. Move each point 2 up. Leave them the same distance on your x-axis, but move everything up 2. So then your picture would actually look like, instead of 0 and 0, you'd be 2 up from that. Okay, and then instead of your 1 and 1, you'd be 2 up from that. So you'd actually be at 3 and 1. Okay. And you can draw it like that, okay? So your picture, are you kidding me? What? Okay, I think we're back. Technical difficulties. Just fell asleep. Okay, here we go. So then your picture would look like this. All it means is all your points are up 2. Whew, that scared me. Okay, but what I like doing is I like changing the table and then drawing the picture. Okay, so what that means is, here's our table, x, y, and we said our points were -2, -1, 0, 1, and 2, right? And now what we're doing is, since we're moving our picture up 2, that's affecting our y, that means all we're doing is adding 2 to each of our y's. So I'd add 2, add 2, add 2, add 2 to get my new table. Okay, so this is now 4 plus 2, so our new point is 6. This is now 1 plus 2 is 3, 0 plus 2 is 2, 3, and then, what are we at? Is that the end? No, 1 plus 2, 3, 2 plus, so we'd be at 6 there. Okay, so this would be our new table, and then you would graph those points instead. Okay, which would give us the same picture because we'd be at -2 over 6 up. Okay, -1 over 3 up. 0 and 2, 1 and 3, and 2 and 6. And that's our picture. So now our original was our x squared, and when we did a vertical translation of 2 up, this is our picture. It just shifted up 2. Okay, what would be happening to this one right here, this equation? Yeah, since it's a -5, you'd think it'd move left, but it doesn't. It moves the opposite. It moves to the right 5. Okay, so what is that going to affect, your x or your y? Your x. So our equation for this, and we make a table, so our y points would stay original, right? So our original y points, if we see them from our original table over here, they were what? 4, 1, 0, 1, and 4. Okay. And now our x points are going to be, what did we say? Added. You're adding 5 to them. Okay, so that means all these x points are just going to get a +5 tacked onto them. Okay, so it's now -2 + 5, you're going to be at 3. And a -1 + 5, you're going to be at 4. 0 + 5, you're at 5. 1 + 5, you're at 6. And 2 + 5 is 7. Okay, so this is our new table. So then if we graphed this, okay, how did I do that? I made that into a eraser. Look at that. Impressive. Now it's a pen again. Okay, oops, yeah, I wanted to do that. So then we go 1, 2, 3, and 1, 2, 3, 4, and make our point. And then our next point was 4 and 1, and 5 and 0, and then 6 and 1, and then 7 and 4. So if we drew it, it looks like this. Okay, so all that happened from our original was this. All that happened is it moved over 5 spaces, right? Each point moved 5 spaces. Okay, so I feel like it's easier to take this table and then change the numbers and then draw one picture. But if you wanted to actually draw this picture and then take this point and go 1, 2, 3, 4, 5, and that's your new point, and make a new point, it gets messy and confusing when we start getting into stretches and reflections is all. It seems okay right now, but then when we get into combining, we're going to do like a stretch, a compression, vertical translation all at once. So you'll be doing like 7, 8 different things. So that means you'd have 7 or 8 different pictures and one final picture. Okay? Whereas this, you have maybe 7 or 8 tables and one picture. Okay? Okay, so we're on to, sorry, I gotta figure this out. Let's cruise. We're gonna do the second example here. Okay. And I gotta erase all this. Okay, so the second example, you'll notice it's all absolute value. Okay, so it's y equals the absolute value of x minus 4 plus 3. So, does anybody remember what absolute value equations look like? Yeah. They don't have the negative because they're absolute value, right? I don't know what that meant. Hopefully that wasn't bad. Okay, so they look like a V shape, right? Because where they would usually be a line going down into the negative, they actually reflect up into a V shape. Okay, so if we were to always go back to what your original equation So what we want to do is we want to look at the original equation. So the original equation for, oh my god, sorry, I gotta go back to my pen. Oh, somehow I'm missing my old smartboard. Okay, so our original equation would just be like an x in absolute value, because that's as simple as it possibly could get, right? So if you were doing a table for that situation, so if I had, say, -2, -2 in absolute value comes out as what? 2, because it always comes out as positive, right? If I had -1 and I put it in for my x, I would end up with what? 1. Okay, if I had 0 in there, I'd end up with 0, never negative. Okay, if I put 1 in there, the absolute value of 1 is what? 1. Okay, and 2 would be 2. Okay, so if I was graphing, sorry, this, we'd be -2 and 2 up. There would be our point. -1 and 1, 0 and 0, 1 and 1, and 2 and 2. So you get your V shape. Okay, that's what a basic absolute value picture looks like. Okay, so now we have to decide what's happening to this. So tell me what's happening right there. Right, it means we're moving to the right 4. Yeah, the absolute value sign, yeah, because it's still affecting the x. So you would say this is a horizontal translation, and then I would say +4 to the right, because it's the opposite of what's happening, right? Yeah, but it's a negative here, right? The negative sign, so it means it's moving right. If it was a positive in there, then it's moving left. So you're right, but it's just, you have to look at the equation, not what I just wrote. So then this guy, he's affecting our y point, right? That 3 there. So what's happening? What is that? Yeah, it's going up 3. So we'd say vertical translation of +3, and you can say up so you know which way you're going. Okay? Okay, so then at this point, this is when I would change my table to my new equation. So this is my table for my new equation. And so all of our x points are getting 4 added to them because we're going to move them to the right. Okay, so we're going to add 4 to each of our x points. Okay, and then what we're doing to our y points is we're adding 3 to them. Okay, so you add 3 to those ones. Okay, so our new table is going to be 4 minus 2 is 2. 4 minus 1 is 3. 4, a +4 plus 0 is just 4. And then a +1 plus 4 is a 5. And did I miss this one? Well, that looks terrible. That would be a 6, right? Okay, and then our y points are getting 3's added to them. So it's 2 plus 3 is 5. This is 4, 3, 4, and 5. Okay, so now if we were going to draw our new picture, we would just plot the points. So we would go 2 and 1, 2, 3, 4, 5. And we would go 3 and 4. We would go 4 and 3. And then we'd go 5 and 4. And then our next point is going to be off, but you can see where it's going. So our picture moved from this original, and now we moved it to the right 4 and up 3, each of the points. Okay, and our last example. What happens if you have the pictures and you got to make the equation? Okay, so you're basically doing the opposite of what we've been doing. So, I think they have, it says, describe the translation that has been applied to the graph f of x to obtain the graph of g of x. So they're saying f of x is your original. So the blue picture is your original picture, and then they want to know what happened to g of x. Okay? And then it says determine the equation. Okay, so we know the equation is going to be what? What shape is this? Right, so it's going to be an x squared equation. Okay, and then something's going to happen because it obviously shifted. Which way? It went left, so it's going to be a positive. So we would have like x plus something in a bracket. I'll put the squared there because it's a parabola. Okay, and then did it move up or down? Down, so it's going to be subtract something. That should be what our equation looks like, right? Okay, so now we just need to figure out what happened to it. Okay, so if we went from this point, 1, 2, 3, 4, 5, it went down, right? To get to that point. If we checked another perfect point on here, say this, 1, 2, 3, 4, 5, it went down. Okay, so it's going down 5 every time. So this should be 5. Okay, and how much did it go over? I'll erase that. So if we check, say this point, because that's the end point, remember 1, 2, 3, 4, 5, it went down. 1, 2, 3, 4, it went over. Okay, so that means that should be 4. And that would be our equation for that line. Hopefully.